Couple more seconds, folks, and we'll get started.
Good afternoon or good day if you are virtual to the routing area open meeting at IETF 123 here in Madrid. This is the note well. All we say is that you note it really well. And this is something more. So note really well. I believe this is all familiar. So I'm going to just skip to the agenda. So, are you doing? Go ahead.
Yeah. So yes, we do have an agenda. So, but before we go ahead with that part of the show here, it would be nice to have some note takers in case there would be like Q&A happening. So this is a shared effort. You know, you can look at your screen and say, yes, it's possible. So please, you know, if you see the opportunity, you know, help us to take notes. That helps us to submit things, you know, and to remember what we have discussed about after the event here. So for the agenda, what do we have today? So we have 4 key topics here. So we have first a short update about the things that happened in the routing directorate. Next, we're gonna discuss some guidelines and some information on what you can put in the operational and management section of all the drafts, of all the great drafts we produce here in the routing area. And then the next 2 presentations, each about 15 minutes, are about security. So we all care about security a lot. There is a lot of focus on those things. Now, if we implement security, it also impacts routing technologies on certain, you know, on different kind of levels. So we're gonna discuss those things in what to take into account and some lessons learned from, you know, the various presenters here. So if there are like no further questions or no additional comments from my co-chairs here, then I think we can start to go ahead. And by the way, so the lights, so here on the stage, we have like big, massive lights in front of us. It's almost impossible to see anything over there. So if you go to the mic, you know, please just shout. Okay, thanks. Yes, Hyman. Yeah, but I need to.
That's all, folks. Okay, so this is Haomian from Huawei, and I'm going to report some statistics update for the routing area directorate. Next, please. Oh, yeah, I should do the control, yeah. So basically, this is talking about who are we, and we have been, we have a few 49 experts serving as a directorate reviewer and appointed by the ADs. And the main purpose is to help the ADs to prepare for the IESG. And there are 2 kinds of review requests, basically the early review, working group last call review. And the motivation behind it is to improve the quality of the documents. So it will be very useful to provide early feedback before the working group last call. So all the chairs are welcome to request the review from the directorate, and more details could be found here. Here are some kind of status update. And actually, we summarize what has been done since 118, that is 2 years ago. And there are totally 170 reviews happened. And from last IETF until now, there are 17. So maybe half-half for the early review and the last call review. And we have the top working groups request is MPLS, IDR, and BES. Okay, so here is the complete list of what has been done since the previous IETF. We deliberately hide the name of the reviewer, and actually each of them doing the good job on looking at the detailed documents and provide their feedback. Almost everything is completed in time. Yeah. So towards the result, we usually categorize it ready, there has needs, has issues, or not ready. And if we go to the previous slides, we can find this not very normal is we have quite many not ready in this specific interval between the last IETF and this one. So it increases a little bit on the percentage of the documents, but basically we have 30% of the ready needs issues and 10% of the not ready ones. And moreover, we are also considering to do some non-routing area, cross-area review as well. So this should be announced in other areas actually to welcome the external working group chairs to request for our review, as long as there are some correlation for the routing area. And the status we are trying to maintain from the behind. Actually, I work with Ran together to coordinate this. One thing we are trying to optimize is the expertise of the reviewers. So sometimes when we try to assign a document, we receive the feedback saying that I'm not as an expert at blah, blah area. So could you please use the others? But we would like to say we really appreciate this kind of cross-tech review. But we would also try to record what are the reviewers' background, technology experience, and personal interest. So we use a wiki page to maintain this, and the people are encouraged to incorporate your own expertise and interest or any kind of restriction you would like to add into the wiki page. And for the assignment, usually when we receive the request, we will start searching for a proper reviewer and almost in a round robin approach. And now the normal frequency is each reviewer will do 1 or 2 every 6 months, I believe. So we just make sure that each of the draft will be reviewed by the proper person and have the right, provide the right and valuable technology feedback. So as this specific time being, so yeah, we would like to encourage people to update your experience and interest and the position you served if you have not done it yet. And we are also working with the ADs trying to allocate to the documents and update the personnel of the team. So if you have any good candidates, you are welcome to recommend to us to have new reviewers, and it will be helpful for us to maintain the queue and the list. And I believe this is the end. Thank you.
Any questions on this particular topic? Okay, thank you.
Okay.
So, and also from the ADs, I think the work that the routing directorate is doing, it's very appreciated. It helps all, our work quite a lot. So, and also to the secretaries, really thank you a lot for managing everything into and putting everything into a good track here. So, Joe.
Hello, my name is Joe Clark from Cisco, and I'm representing the authors here for this work in guidelines for considering operations and management in IETF specifications. This is a BIS on RFC 5706. That's the work, and I truly appreciate the ADs allowing me to have some time here. So hopefully we'll get some good discussion and I can get through this in short order. So why did we take this on? Why did we take on a revision on RFC 5706? It was first published in 2009, and maybe for the most part got forgotten over the years. And when we went and looked at it, it was quite stale in that it referenced SNMP, MIBS, COP, protocols that just weren't as used, or in the case of like SNMP, there were statements by the IESG to stop read-write objects in SNMP. So we definitely had to modernize this for one thing. So coming back after 15 years, let's make it fresh. Let's also consider some of the challenges that we run into throughout the IETF when it comes to network operations or protocol extension operations. Oftentimes, these are left for very last, meaning a working group last call. We just heard a director read out. ADs, or rather working group chairs, will say, you know what, we probably need a review from Opster here. And they'll send the Opster review out, and the member of that directorate will come back and say, well, I think you should have considered this and this and this, or what about this? I know as a member of that directorate, I've done these things. And the response is often, thanks, but we're not going to make any changes at this point. It's too far along in the process. Well, we wanted to say, well, if we did something and if we went out and we advertised it early on and we got working groups across all areas thinking about how does this new protocol or this protocol revision impact operations? If we get them thinking not just about that esoteric or abstract thought, but very specific, concrete elements of operations, could they fold that in earlier in the protocol development process? So that was our goal, to influence the working groups working on these new protocols to think through what might impact, or what the impact of their work might be towards operations and management. Very concretely, one of the things that we decided we wanted to do was introduce a more or less mandatory section, the naming is still being discussed, into documents like operational and management considerations. And have that be a very explicit thing, so that you think about this, just like you do with security considerations. You think about these things, and maybe there's nothing. Maybe your work has no relevant management or operational considerations, but instead of omitting it by omission, you think through and you say explicitly, nope, we've thought about this and this is why there are no considerations here. One of the things that we as the authors decided was that we wanted to make this mandatory only in the standards track. And one of the early reviews we got from Alvaro was, why? Why not make this more mandatory everywhere? So that's one of the open questions, and we'd like some feedback on that. Should this section be something that is generally mandatory, and one would explicitly explain why that isn't necessarily needed in a particular document? I won't read all of this. Wow, this is a really nice screen. I won't read all of this even so. I mean, you can choose to read it, but I will highlight some of the aspects here. What we're not trying to do is come up with some comprehensive or overwhelming list of things, some kitchen sink of management or operation protocols or even approaches that you would have to look at. We're just highlighting things, examples that you might consider. How does your protocol interact with that? What might your protocol need in order to be more easily deployed or adopted? We're thinking about or trying to fold in feedback across multiple areas. So not just the ops echo chamber, but what does routing area think? What does internet area think? What do some of the other areas, what would their feedback be that we can incorporate into here to make a really powerful document that people want to look at and want to consider when they're writing their new protocol or protocol extensions. One of the other things that came out of a recent workshop that the IAB ran, the NEMOPS workshop, which ran last December, was operators were expressing a concern or a desire that tooling doesn't necessarily exist or isn't easily found for some of these new protocols, like, for example, Yang-based management or operation techniques. So one of the things we wanted to fold into here was a consideration, not that you have to build tools, but look at what tools may exist in your space with the protocols or related protocols that you're building, and where might new tooling be needed? Or what would you say could be enhanced in existing tooling in order to deliver the kind of management, the kind of deployability and operations for your protocol? Finally, the last bullet, that's that deliberate nature of this. We don't want you just to say, well, we didn't include it, therefore it's not needed. It's like by omission. If you don't think there is any additional considerations, we want you to be upfront about that. Very explicit. Include the section, the null section, if you will, and explain why you don't think there are any operational or management considerations. Our current plan is to release this as a BCP. We're working on this in the ops area. And by ops area, I mean like the ops area open meeting. That's where it'll be discussed. We used to fold ops area in with the ops area working group, and we would have in these in-person meetings, we would have a joint meeting. We're breaking that out. Our new AD Med, he wants to sponsor this and he wants to take action. He wants to start moving this forward. Alvaro Ratana has graciously agreed to be the document shepherd. I think I see him back there through the lights in all of this, so we thank him for that. So far, we've made great progress. We meet weekly, the authors. We use GitHub and Markdown for authoring all of this. We just published revision 3, but we just got a lot of feedback on that, so we're going to be incorporating Alvaro and Chongfeng's feedback and coming up with an 04 relatively shortly. And finally, this is where you can go. You're welcome to file issues in GitHub if that's your thing. If it's not, generally the conversations have been happening on the Ops AWG mailing list, and we're happy to take feedback there as well. And in addition to where this might be mandatory, all tracks are just standard, general discussion, how can we make this useful for you? And it looks like I've got about 2 minutes for discussion. Everyone's hitting the abstain button at their desk. Well, if no discussion, reach out on mailing lists if you want.
And I switch my mic on rather than switching it off. There must be some questions, some comments. I know it's just after lunch. We're all kind of sleepy.
I see Alvaro in the queue.
Alvaro Ratana, Futureway. Hey, Joe.
Hey.
So as Joe said, I'm the shepherd for this thing, so I actually read the draft. Has anyone else read the draft? I don't know. So I just want to say thank you for the work. And I think this is really important. And the reason I think this should be mandatory for every document is because I believe that we're all here to make things work, right? We're all here to define protocols for the internet and things that we hopefully get deployed. And if they get deployed, they have to have an operational consideration, right? You need to think about how you're going to use the protocol, how it's going to affect whatever other things you have in your network. I can think of very few cases. Maybe you're defining a new bit somewhere that has no impact on anything, but then if it has no impact, then why are you even doing it? So, in my opinion, everything has to have operational considerations. Just like we think about security today, if there's nothing major, as Joe said, we should include something. So it would be really good that everyone thinks about this, because it is going to create not a lot of work, but a little bit of extra work on the documents.
Thank you.
Yeah, one comment I would make. Well, firstly, thank you for the presentation. And from an AD perspective, what I've observed anyway is that when we get documents come to us, and before we send them to the telechat, we always send them to all of the directorates, basically Ops, Security, Routing Directorate, and 9 times out of 10, what I see is comments coming back from the Ops Directorate that could have been addressed way back. So anything that we can do that is going to help speed up the process, because we are getting those comments from Ops, and those documents are getting updated, but it's late in the process. Mm-hmm. So if we can do it earlier, that's a positive thing.
Thanks. Yeah, that's our thinking exactly. Benoit, thank you.
Benoit Clay. So actually, you just answered the question I wanted to ask. I wanted to ask you guys as AD how you would see this, because being part of the ISG, you see all the tensions that we have that says, well, it's too late, but actually we could have done it earlier. So you answer the question I wanted to ask you. Thank you.
Thanks. I think there's one more.
Yeah. Hey, John Scudder, HPE. Oh. Yeah, so 2 things. One is I want to push back just a tiny bit on Alvaro, because that's what I do, which is to say I completely agree. Anything that is protocol related, is related to being deployed in a network, absolutely. I'm not so sure that, for example, the output of Mod Pod on moderation of IETF mailing lists needs this section. So I would leave like a little tiny wiggle room for people to just leave it out, instead of having, this space intentionally left blank, other than this notice, which is, we all have to do it sometimes, but it's a little embarrassing. Second point, and I think this is a little bit of repeating things that have been said, but I think it's important, is this mandatory section will be useful in proportion to how early people start to pay attention to it in the document development process. So I think that we're going to need chairs and document shepherds to, start prompting their authors to say, okay, great, you've put in the mandatory heading. Now start to put in something real, like maybe go read the considerations document instead of just like sticking in the heading that acknowledges you're supposed to put something there. I can't tell you how many times I've had to struggle with this with security considerations, and I'm still not sure that I've shepherded through documents with great security considerations. People, for any kind of boilerplate, they want to do it late. So it's going to have to be a group effort if we want this thing to be really useful. But thank you for doing the work.
Yeah, as an anecdote, I recently did an Opster review. Maybe it was a routing document, and I pointed to 5706, and they said, "Thanks, I didn't know this existed." And I think more of that would be good. And to your point earlier, is better.
Okay. So taking on from security considerations, for a lot of protocols and technologies, we have some base documents that describe the security considerations of that protocol. And every incremental document that adds extension is then only covering that bit of extension. If the operations consideration and management consideration follow in the same line, I think as a group, we may need to look at whether we have the base operational and management considerations for a protocol in place, or somebody working on them. Otherwise, it may be very challenging for, like a document comes on which does 1 bit extension, and then the questions may be like, okay, there is no base to refer to. So
Yeah, we haven't really talked about how, obviously we can't retrofit these considerations into older documents as they BIS, or if they BIS, we could. But it's a good point. It's something that we haven't yet discussed amongst the authors, is what guidance would we give in that kind of situation. It's a good call. Okay, I'm well over time. Thank you again for this opportunity.
Thank you so much. I think it's an important topic because, we always, we all end up with this operational section. We don't really know what to exactly write in there, and this actually helps us a lot. It also brings me, gives me another idea. So maybe we should actually create like a mandatory routing consideration section in all drafts which are created at the IETF. So, okay.
So hello, my name is Olivier Bonaventure. I'm professor at university in Belgium, where we do research on transport layer and on routing protocols. So for transport layer, we built multipass TCP, multipass quick. And in routing, we did ordered fib update. We did extensions to BGP. So I'm both on transport and routing stuff. And Gunther asked me to do some presentation on what happens when you do secure transport in a routing context. And so I tried to divide the presentation in two parts. First, a generic discussion on secure transport, and then some recent experience that we have in using OSPF and BGP over secure transport to show you some of the issues that we found. So if I look at the security techniques that exist in routing protocols, when I explain them to my students, basically I say, well, there are lots of security techniques, but basically it's packet authentication, and the router can check whether the packet which is received has the right authentication, and there are different solutions, different syntactical details, but basically the idea is that we protect the routers from receiving packets that do not have the valid authentication. And basically that's what is being done. And then I looked at recent RFCs, and there is an RFC that was published in December 24 on ISIS fast flooding, and it reminded me of some old work that we did. And so I looked at the ISIS specification, and the ISIS specification says that there is a limit on the number of LSPs that you can send. So you can send one LSP at most every 33 milliseconds, and you can be sometimes faster, but not more than 10 in a row. And 20 years ago, when we did fast flooding with Cisco and Clarence Fils, we looked at this issue, and one of the early low-hanging fruit to improve the conversion was just to get rid of this limitation in ISIS and make it go fast. And then I was surprised that it took the IETF 20 years almost to have flooding parameters to control the ISIS timers. I would have expected the IETF to be a bit faster than that. I knew that it was slow in other parts, but not in this one. And then I was really surprised to see in this RFC that there is a receive window and there is some congestion control, which is really strange to invent flow control and congestion control in a routing protocol, while we have lots of stuff in the transport protocols. So flow and congestion control are stuff that are solved by the transport protocol. You can look at TCP, you can look at SCTP, at Quick, and we have mature implementation with lots of experience. And I think it's better to go in this direction than to go on reinventing specific protocols for specific routing protocols. So just to look at what are the possible secure transport protocols. So there are two possibilities. You can run TLS over TCP. If you run TLS over TCP like everybody does on the public internet today, the advantage is that TCP is general purpose. It's already widely used. You have mature code. You can leverage the TLS certificate, and there will be a discussion with Jeff Haas later on how to leverage the TLS certificates in routing protocols, and that's the important part of the discussion. In TLS, if you go in the TLS direction, you will have TCP that secures the payload, but not the TCP headers. So using TLS only does not protect you from reset attacks or from packet injection attacks in TCP. And TCP is mainly in the kernel, and there is no multicast support. So if you want to use a regular transport protocol in a LAN where you have multiple routers like OSPF or ISIS that exchange information, you cannot use multicast for that. You have QUIC on the other side. So QUIC is mainly targeted today at HTTP3, but there is an ongoing work on putting a BGP above QUIC. And there are several implementations of QUIC that are well running and well interoperable. We use the same TLS certificates as for TCP, and QUIC will secure both the payload and the packet header, except the IP address, but it's not important. You can have multiple byte stream, and this is leveraged by the BGP implementation. And it can also support datagrams if you don't need the reliability. One point that I would like to raise to inform you about QUIC is that there is ongoing work on doing extensions to do multicast with QUIC. And so if you want to go in the QUIC direction for intra-domain routing protocol and you want to exchange information in a LAN, this might be possible to do with QUIC as well. Looking at TLS over TCP, as I said, in TLS over TCP, you do not protect the header, the TCP header, so you still can have packet injections and reset attacks. The solution for that is to use TCP-AO, and the only use case for TCP-AO is to protect BGP sessions. And the problem with TCP-AO is that you need to have a secret key which is shared between the two peers before they can open the TCP connection. In fact, it's possible, and there is a draft where we describe that. So it's possible to combine TCP and TLS together. And when you open a TCP connection using TLS, what TLS does is that it will negotiate a secure key. And once you have negotiated a secure key, you can derive another key which can be put inside TCP-AO to secure the TCP header. So in a nutshell, the idea of this solution is that you start the TCP connection using AO with a well-known key that everybody knows. So the TCP connection is accepted. You negotiate TLS. Once you have negotiated TLS, you have a secret key, which is only known by the peer. And once you have this secret key, then you can derive the key which is used to protect the remainder of the connection. So for the long connection, the connection is not protected for the first 10 packets, but afterwards, it's always protected by using TCP-AO. And there is an implementation that shows that it works without any changes on Linux. So now, looking at some recent work that we did with BGP and OSPF over secure transport, we have published last year a paper showing that what can you do when you put BGP on top of QUIC or BGP on top of TLS and TCP, and what's the impact and what's the benefits of doing that. So the impact, so we have proposed there to use TCP-AO with the key derived from TLS, and it works. And we have extended the Bird BGP daemon to be able to support it. And doing the extension for Bird was relatively simple. We also did the extension for BGP over QUIC, not the QUIC corresponding to the draft which is being discussed at the IETF, but a simple version of QUIC which uses a single stream. And when we looked at the performance, we saw that doing encryption slows down a bit the BGP performance compared to BGP without encryption, which is not surprising. But you can see in the paper there are more details. One point that I would like to mention about that is the main benefit of using BGP over secure transport is that you have certificates. These are not the certificates that you use today on the web to access web pages, but they will bind a public key to a specific role, and you can use that to authenticate a peer by binding the certificate to an IP address, to a set of routers, to a set of peers of customers, and Jeff will discuss that later on. And once you have certificates that are exchanged to establish the BGP connection, the BGP session, it's possible to use that for other purposes. And let me give you one example, which is shown in the paper, and there are other examples that are possible, but in a certificate, you can add additional information. And the additional information that you can put in a certificate could be a configuration command or could be netconf commands that you put in the certificate. So the use case was suggested by a friend who is running an ISP. He told me that in his ISP, they have a set of customers. They have many VPN customers. And these VPN customers, they always come with new ideas on new ways of configuring the quality of service of the link between the provider and the customer. And as an operator, my friend told me, well, I don't want to have to change the policy on my PE router every time my customer has a crazy ID. And I would like a solution which is as automatic as possible and which scales for a large number of customers. And one possibility is to say the ISP could generate a set of certificates, and these certificates contain the commands that needs to be activated on the PE router by the specific customer. So let's say you have a customer who wants to have 3 different quality of service policies. Let's say daytime policy, nighttime policy, and one policy when the chairman is doing a video conference. And the customer would like to change the policy as they wish. So one possibility is that to say that the customer, if you want to change your policy, you just change the certificate, you restart the BGP session, and by restarting the BGP session, you redo the exchange of the TLS certificate, and then the TLS certificate pushes the new configuration on the PE router, and the ISP, the network operator, does not have to do any change in the configuration, only accept the certificate that it has provided, and the certificate that it has provided, they are signed by the operator, so they cannot be changed by the customer anyway, and they can be opaque if you want them to be opaque. Second example, we have also played with running OSPF over QUIC, and our main motivation for that was to be able to do ordered FIB updates, so to be able to update the FIB of the routers without causing transient loops when you are changing the IGP weights. And the benefit of QUIC in this scenario was that we have reliability for the exchange of the OSPF packets without any, we can leverage that to build an ordering of the FIB updates, and there are more details in the paper. So just to conclude, so from my viewpoint, the routing protocols, they should leverage the existing secure transport protocol and not invent their own solution. And the move to BGP over QUIC goes in the good directions. And QUIC alone or TCP with TLS, they bring efficient flow control, reliability, congestion control if you need it, a strong security feature, and mature implementations with operational experience. Thank you. Do you have questions, comments?
AC Linda Marcus, did you implement the multicast extension to QUIC for the OSPF or just do point-to-point when you did it? It'll keep me from having to read the paper.
What do you mean by the multicast extension to QUIC?
Yeah, I saw you referenced a draft.
Yeah.
Nambara or somebody that QUIC supported a multicast. I didn't know it did. And I saw you did.
So it's a draft that we have proposed. It's not yet accepted by the IETF.
Right, exactly. Did you implement that to do?
Yeah, we have an implementation on top of Quiche, and I will be happy to discuss.
And did you leverage that for the OSPF, or did you
not
just
yet for OSPF?
No, you just did the point-to-point then?
Yeah.
Okay.
For OSPF, we did the point-to-point. But if you have a use case for OSPF, I'd be happy to discuss with you.
Well, if you want to do it on other types of networks, you would need to do it, like broadcast networks.
Yeah, but we can do it. So we have the implementation.
David Lamparter, actually related note, the multicast QUIC extension doesn't do initial multicast. You can only do multicast after you've established a point-to-point session. Like you cannot use this for discovery like the hellos in OSPF.
So the draft does not explain how to do it for discovery, but we have other work in progress where there is a possibility to do it for discovery, because in QUIC, you have a preferred address and you can rely on the preferred address to do some discovery. So there is a hack which is possible for that.
Maria, I'm a maintainer of BERT. First side note, thank you for using BERT. Are you, I hope, thinking about contributing this work explicitly to the main line, or are you expecting to keep this work just to rot away and not be like included in the main line? And the second thing is, well, I still can't see what we are actually protecting with the TLS, because everything I can see here is actually protectable by the TCP/AO, and as soon as we start doing TLS, we are just starting using another thing as a hammer on something which looks like a nail. You just have a big hammer. This is not a nail. Thank you.
Now, so two comments. So the two implementations, they were done for the paper, and we are happy to contribute them If you believe that this is a useful contribution for BERT, but I expect that you would like to have something which is standardized before having a contribution to BERT. So in terms of stability of code, the BGP over TLS is more stable than the BGP over QUIC for practical reason. And I think having certificates is a very good motivation, and Jeffrey will explain that later on. And even if you have certificates and the cost of doing the encryption for TLS, the benefits of the certificates are more important than that. But I would be happy to discuss with you later on.
Yeah, let's take this offline, and I will have probably another comment to Jeff's presentation, but let's leave it for later. Thank you.
Marwan Fayed, Cloudflare. So I'll give you another reason actually for the quick case, which is call it a bug, call it a feature. When the TCP connection fails, the BGP session closes, all the routes are withdrawn. If you have quick, we have a connection ID. It's much easier to migrate one endpoint of the connection without tearing it down and creating all kinds of havoc.
Yeah, so that's a benefit. But I think there are some points that would need to be discussed in the BGP over QUIC draft, because in the BGP over QUIC draft, there is support for connection migration. But if you do migration and you lose an IP address, then the prefixes that are bound to this address, what do they become? And so you can change an address, but in the BGP scenario, you have to be more careful than in the web scenario. But I agree that there are some interesting points to be done.
Thanks for the work.
Hi, Jean-Michel Combe. With BGP over QUIC, do you use encryption or just authentication and integrity?
Both encryption and integrity, both.
And so why do you do encryption? What is the threat?
By default, QUIC is doing encryption. And so if you want to do QUIC without encryption, then you have to remove some stuff from QUIC, which is a bit boring from a software viewpoint.
Thanks.
Thank you, Ali.
Hello, Bob. Would you let us know you can hear us, and can you speak?
I can speak. I don't know if you can hear me, but I can hear you.
Yep, and we see your office too. So that's
good.
Great. So, the coincidence of the presentations being back to back, that was not an expected thing. I actually was not paying attention to the agenda. I was like, oh, Olivier's here too. So that's a wonderful thing. So our motivation started from a slightly different perspective. I'm involved in work for BGP over QUIC. Our motivation is, a little less, doing standard transport, stuff for BGP, and there's a little bit more about using streams for something like BGP. And we've been very happy to see that the stuff we're doing is driving a lot of attention of QUIC in routing protocols. We had left out some of the details intentionally about the security stuff, simply because we wanted to make sure we got good expertise on it. That said, sort of in parallel, we'd had conversations over the years with the ADs, especially the security area, about how do we do transport security profiles for routing protocols. We're routing people, we don't have that expertise, and we ideally want these things to be boilerplate. So since we're looking at QUIC is just basically a thin transport wrapper on top of TLS. This means that most of what we're doing is interesting TLS things. So just hitting a couple of things in review, and Bob and I will be taking some back and forths. Transport has been around for ages. BGP has been using it for a while. One of the things that we usually end up pointing out here is when BGP started using TCP. It's mostly because the expertise of Yakov and company came from EGP and having their own hand-rolled transport that failed spectacularly. So they wanted to use something that was supported by somebody else. But TCP is largely what we've been using. It works. We just care that we have a reliable streaming protocol, and anything that we can use to shove around a stream of bytes will do the job. Security obviously was an afterthought, just like a lot of the stuff at the time. And we evolved IPsec. People do deploy IPsec and it works. TCP/AO replaced TCP/MD5, but support for it has been erratic. Now we've only seen it starting to show up actually in stacks recently. For the most part, routing people as security people, and one of our common dialogues with the security area is, please put security on top of things, which might include properties like privacy, means that you have to have this conversation. I'm just writing this routing protocol thing. How do I get it? If you can set a socket option for TCP/AO, you're done. TLS, other things like that, you require more help. Privacy, as I mentioned, it's not really a thing, and this was, Maria sort of hit the point in the earlier. Why do we actually care about it? For the most part, in routing land, we don't. We do occasionally have use case scenarios, customers, pick whatever the use case is, where hiding stuff actually becomes important. Our security reviewers always want to know at least what we're thinking about for it. So if it's an optional thing, that would be great. Another thing that we don't have as a core property for most of what we do is authentication. For the most part, our routing protocols are thing A is talking to thing B either directly across the connected network or intentionally across the configured set of networks. So endpoint security is where we normally do most of our stuff. We have tools like firewalls and GTSM to help us out, but authentication is sort of an afterthought. But since we're looking again TLS, we get to have that conversation. And my last slide, we're handing off to Bob for a little bit. So TLS 1.3 for routing protocols, which is effectively what we're talking about here with QUIC as well. We get privacy via encryption mechanisms. That's great. We get the integrity properties that we want out of some of the things. We get authentication via certificates, which, as we talked about when we did foo over QUIC, last routing area, is an interesting thing and scares some people. But part of what we're going to be talking about here is why it should not scare you. Unfortunately, and Olivia already hit this point, TCP/TLS is vulnerable to reset attacks. And for BGP sessions that can live for years, this becomes a critical thing. And I was actually thrilled to see the work that they've been doing to actually allow TCP/AO to be picked up. And quite frankly, if it goes no further for routing purposes, this is something I'd encourage them to continue moving forward because it's a useful feature. Our presentation is mostly about what do we do with these certificate things. Over to Bob.
So my background is I'm definitely not a routing person, but I tend to get sucked into conversations with routing people. I'm mainly a TLS person. So to just speak a little bit to certificates and how this kind of applies to these sorts of things. If certificates scare you because of things you've heard in the past, this is understandable, and there's certainly been lots of issues with this over the years. X509 certificates back in the day were designed with this idea that you would end up with one glorious thing, you would have one certificate that you would be able to use for everything, and you'd carry it around like your driver's license, and it would do all the things. All the things would be in this certificate, and everybody would trust this certificate for you, and this would be great. And what's found out over the ensuing 20-25 years is that everybody trusting everything is just a model that doesn't work. So a lot of the things that we hear about with issues with X509 and stuff like that, and great big things in certificates, this comes from that. And what has been happening in the modern world, and as we even see this in the web PKI as the web PKI, and when I say the web PKI, this is the thing we think about for using certificates for web and HTTP connections, is that these PKIs are starting to move to a single PKI for a purpose. So you are starting to see things where, for example, in the future, you won't be able to use your web server certificate for email, things like this. It is starting to move to specific things for a specific purpose, with certificates being much more focused as being for just one thing. And so when we think about routing in BGP, really what you want with a certificate is it's a certificate to do just one thing. It is to prove the identity of an endpoint of a BGP connection. So, and normally, you know, this means you get a certificate with a certificate chain from an agreed on trust anchor, and we want that to use for authentication that has just the information we need for BGP. So what do we need for BGP? Back to Jeff for a sec.
Yeah, so this slide here, so we're talking about, you know, what do we want to use for BGP, you know, and this eventually moves to talking about it more broadly. BGP, again, cares about configured endpoints. When you configure BGP, here's your addresses, your autonomous system numbers. You know, in terms of the transport configuration and the session configuration, they're basically the same. In terms of securing it, we want to actually secure the endpoints. And, you know, why do we actually care about that sort of thing? Well, a lot of times there's going to be circumstances where you think you're plugging into somebody that just because they're claiming to be some provider doesn't necessarily mean they are. They could be, you know, masquerading as somebody else. Having a certificate infrastructure gives us a tool to maybe, you know, address that. BGP's AS number based, so a certificate, you know, chain that, you know, one of the trust anchor points happens to be an autonomous system number means that you can use the AS number certificates as a way of saying this is the thing that you're trusting for the AS, and then potentially, in some circumstances, trust, you know, everything that is derived from that chain, which allows them a provider to mint new certificates for transport endpoints using their own AS, you know, certificate. So what we're looking at here is how do we do a certificate profile specific to BGP-like things to say who we are as an AS. Is this endpoint is the thing that we're actually testing to, and it's usable only for this purpose. Now, we saw that Olivier and company have some ideas about other stuff you can put in here. We're looking at more of a, you know, tight purpose for this sort of thing, and I think this will be part of the interesting discussion. But in terms of, you know, what do we actually do? Well, this is what profiles look like.
And so when we talk about a certificate profile, what we're really talking about is you know, we write down things in a draft that say, for this purpose, we expect a certificate to have particular properties and particular properties only. And what this might look like is if we have a signing certificate that specifies the AS, possibly identified by an OID in the certificate, this could itself be signed by some mutual third-party CA. You could even imagine having your own set of CAs that you mutually trust. The CA would need to be able to verify AS control before signing such a certificate. And we would probably want all certs to have a specific extension that's more or less we could register something that says, hey, this is for BGP and it's only for BGP. The thing you don't want to get into is a situation where we have cross-protocol things where all of a sudden somebody mints a certificate for, you know, email or for an IP address for a web server, and oops, because this is mutually trusted, this also can be used for BGP. We really want to be looking here at a specific PKI that is just for this purpose and this purpose alone, and have stuff that and the properties you're really looking for here when we think about this are, we'd like to be able to validate these chains with a standard verifier, so implementation is easy. Okay, we don't want to make something that requires you to make modifications to a TLS stack in order to implement this. And we still want to be able to know that we're not going to accidentally accept certificates minted for some other purpose. Leaf and end entity certificates could look more or less like a conventional cert with a single SAN IP addresses and either TLS client or TLS server EKU. And that seems a little weird for BGP because it's just mutual peers, but client in this case for TLS is the connecting, the one who makes the connection, and the server is the one who accepts the connection. We'd want to make sure that it's only, you know, that it's only, and the thing that might look scary here is short-lived one-day leaf to ensure no revocation checking in leaf. Now, one day is to get you thinking. This is not something that we would necessarily say has to be a day. It doesn't have to be, you know, it can be, maybe it's more, maybe it's less, doesn't really matter. But if automated provisioning is the norm, and we know that, you know, any router has, you know, any peer has the ability to get a certificate easily and automatically provision this, these things shouldn't last that long. And that means we don't have to worry too much about revocation, which is a nasty problem for to have to hang over yourself, because CRLs are kind of limiting thing, and they're sort of a pain to use, but they work for smaller PKIs. And if we think about the size of the AS space in general, while we might not want to have revocation for all of these leaves for particular endpoints, the AS space isn't very big, and if the AS intermediates live for a reasonable amount of time, there's not really a problem having CRL lists for those. So for an example here, we think router 1, AS64, each router has an AS. R1 makes the connection, and in TLS, this will mean the connecting thing will request the certificate from the other end via TLS 1.3. R2 will send a TLS server auth with its IP address that's signed by its AS intermediate, and it will request, this is how the TLS handshake works, it will ask R1 to provide a client certificate. R1 will then send a TLS client auth certificate, the same thing, also signed by its own AS. R1 and R2 can then more or less run, what the desire here is we have a certificate profile set so that you can run the standard RFC 5280 validation over that chain. As a result, no, the chain is valid, we each trust each other, okay, we then make a check for the BGP specifics and we continue. And we don't want to use the third-party PKI in any current form. The web PKI is not good. It won't be good for this. The web PKI is focused on the web. We want to be able to focus on routing protocols. RPKI is interesting because RPKI also uses certificates and also has a chain of trust that is being deployed in this environment. But the contents of RPKI objects are for a different purpose, and they're not valid for conventional TLS sessions. We really don't want to cross the streams here. We want to let RPKI do RPKI. Right. And that's about it. Jeff.
Yep, and we're down to our last minute or so, so we're going to just blaze through these last couple slides. That's great. We've hit all the important certificate stuff that's interesting about this talk. The TLS gotchas, this is actually a thing we brought up as part of our BGP over quick thing. The batching that the crypto layers do for TLS gets in the way of routing protocol timeliness type things. You don't want to do tight BGP keep alives with this sort of thing. It will get in your way and fail. So this is part of the thing we have to think about as we start looking at applications for TLS and quick, for routing protocols. Quick has keep alives, TCP has other things for helping out with TCP hellos. You're probably deploying this with BFD as well, but it means you have to take care of that sort of thing. And to pick a relatively sore point, people say, well, this privacy stuff gets in the way, debugging's hard. That used to be true, that's not true anymore. So that's less of a problem. I'm just going to blaze through these if you don't mind, Bob. So, back to the certificate lifetimes. The easiest way to think about it is when you get your certificate, it's like having a driver's license. As long as it was valid when you actually went into a liquor store to go buy something, it's still valid. You haven't stopped being the same person. Revocation means something very different for routing protocols, but that's going to be part of our conversation. And the same thing's true about what we want to put out in certificates that are other things. Well, we can have other things, but let's keep these things at least simple for the get-go. And our last slide is that, well, we've been talking about BGP. Well, obviously this can be used for other internal routing protocol purposes as well. That's going to probably resemble some shape at BGP AS. And one of the interesting next step things where this goes is once we gotten to the point where we like the idea of minting certificates for something that's going to be used for validation, something like Acme might be able to help us mint these things, and that hits into zero-touch provisioning. So there's some possibilities there. In terms of future work, clearly we had a collision in terms of people interested in stuff. We have no egos tied up in actually getting a specific draft out at the moment. We're looking to actually provide infrastructure for the IETF and security boilerplates routing people can use, so you don't have to worry about all these. How do you make the security ADs happy? For the rest of it, we'll figure it out from there. Thanks for your time.
So we have 3 people in the line here. But we only have like 2 minutes left. So Rudiger, you have like 20 seconds for your question.
I
I am kind of questioning whether it is an operationally nice idea of having two separate, unrelated X509-based certificate systems for BGP-ASs. The RPKI quite certainly does not provide TLS certificates straightforward. And the RPKI was, when it did the AS certificates, was thinking more about BGP-SEC than authenticating the BGP sessions. But kind of it looks really weird to do certificate assignments and validation in parallel into completely separate parallel systems.
Right, to answer you, Rudiger, before I hand it over to Bob for 30 seconds, we did actually have Job Snyder say, is like, hey, why aren't you hooking this into RPKI for your trust anchor? We don't object to it. Bob has some thoughts on that.
And it's not actually that unusual, even outside the world. If you think about, oh, I have a separate X509 infrastructure for my web server versus my email server, and that's going to be the norm. And the nice part, and I think if you notice there, is that there is ways to still relate them. So, for example, if you are dealing with automated certificate issuance, you want to prove control of the AS. I think that's the place to tie the two together and talk to perhaps my friend Job about getting a draft together to say, here is how to have a message type for RPKI to prove control of the AS, which could be used then to say, oh, okay, it's okay to issue a certificate for an AS certificate to the person who can prove control of an AS by signing something with the AS RPKI object.
All right, so I'm going to have to jump in, folks. We're over time, so we're not really going to have time for the rest of the questions, but I'm sure you'd be happy to talk to people offline and get feedback and stuff. Thank you, everybody, for attending. That's it.
Thanks, Bob.
Yeah.